Something strange is happening in the depths of our galaxy. A star, once thought to be just another quiet point of light, is now screaming across the cosmos, sending out bursts of radio waves so bizarre, so unexpected, that astronomers are scrambling to explain it. These aren't just ordinary signals. They flicker on and off with no clear pattern, changing their rhythm like a heartbeat in distress. At first, scientists thought it might be equipment failure. Then came the realization, this star is unlike anything we've ever seen, and whatever's going on, it's not following the rules of any known cosmic behavior. What kind of star sends messages like this? Could it be dying? Is it being torn apart by a hidden force? Or is there something entirely new out there? Something we've never imagined? In this video, we'll explore what's causing these strange radio waves, how this star might be, breaking the laws of physics, the theories scientists are racing to prove or disprove, and what this could mean for the future of space discovery. The star in question lies thousands of light-years away in a relatively quiet region of our Milky Way, known to scientists as Gleam X J162759 5523504 Yes, a name that sounds more like a computer password than a celestial marvel. It was barely a blip on our radar until very recently. It's located in the southern sky, invisible to the naked eye, but it suddenly burst into the spotlight when radio telescopes in Western Australia picked up something completely unexpected. Powerful, repeating radio pulses that seemed to flash every 18 minutes. That's unusually slow for a pulsing object. Most cosmic signals we've studied, like those from pulsars or fast radio bursts, blink in milliseconds or seconds. But this was dragging on, like the slow tick of a massive, invisible clock. Astronomers were stunned. This wasn't just rare, it was unprecedented. Never before had we seen a cosmic object send out such regular slow radio pulses for weeks, at a time only to fall silent again. Some thought it might be a magnetar, a type of neutron star with an insanely strong magnetic field, but even magnetars don't usually behave like this. Others considered it might be a white dwarf with peculiar properties, or perhaps something entirely new. Whatever it is, it's forcing scientists to re-examine what they thought they knew about how stars live and die. This discovery may be the first of its kind, or the beginning of a new class of cosmic objects we've never encountered before. 2. Understand what might be happening with this mysterious star, we need to zoom out and look at how stars work in general. Most stars, including our own sun, are essentially gigantic fusion reactors. Deep in their cores, they fuse hydrogen into helium, releasing massive amounts of energy that pushes outward and balances the crushing force of gravity trying to collapse them. This balance is what keeps a star stable for millions or even billions of years. But as stars age, they change. They run out of fuel. Gravity begins to win, crushing the core tighter and tighter. For some stars, this leads to a violent end, a supernova explosion, or the formation of incredibly dense objects like neutron stars or black holes. And it's here, in this final phase of life, that some stars start acting strange. They can spin rapidly, shoot out beams of radiation, or collapse into exotic forms that challenge our understanding of physics. That's what makes this star's radio pulses so fascinating. They may be a clue that we're witnessing a transition, something shifting deep within the heart of this object. One theory suggests it could be a magnetar, a kind of neutron star with magnetic fields so intense they could erase a credit card from thousands of kilometers away. Magnetars can sometimes emit bursts of energy, but the rhythm of this star doesn't quite fit. Another idea is that it's an ultra-long period magnetar, a theoretical object scientists weren't even sure could exist until now. Or maybe it's a white dwarf, the burnt-out core of a dead star, somehow managing to generate these radio bursts. To investigate, astronomers are using everything from the Murchison Wide Field Array to the powerful Parkes Radio Telescope. They're also checking data from the Hubble Space Telescope and looking for any accompanying signals, like X-rays or even neutrinos, that might give us more clues. If gravitational waves are involved, observatories like LIGO could eventually detect ripples in space-time caused by this star's activity. The truth is, we don't yet have a perfect answer, but the behavior we're seeing might mean this star is nearing a critical moment, perhaps spinning down, collapsing further, or preparing for something we've never seen before. Here's where things get even more fascinating, and a little mind-bending. Because this star is located over 4,000 light-years away, everything we're seeing actually happened 4,000 years ago. That's the nature of space. Light takes time to travel, so when we detect those strange radio signals, we're really looking into the distant past. Whatever caused them might have already changed, evolved, or even exploded long ago. We're just now catching up to the light and energy it left behind. So, could this star explode soon? Maybe. Or maybe it already did, and we're waiting for the cosmic aftershock to reach us. If it's on the brink of collapse, it could transform into a magnetar, a black hole, or trigger a supernova. And if it does go supernova, the sight could be absolutely spectacular. Some supernovae become so bright they outshine entire galaxies for days or weeks. From Earth, a nearby supernova could be visible even in broad daylight, shining with the intensity of a full moon, casting shadows at night, and dominating our sky like a second sun. Astronomers don't know the exact timeline. It could be decades, centuries, or perhaps we'll never see the final flash at all. But every strange pulse brings us closer to understanding what's coming. It's like receiving ancient messages from a ticking time bomb in space, each one whispering, "Something incredible is on the way." Imagine stepping outside one evening and noticing something unfamiliar in the sky, an intense, glowing point of light that wasn't there the night before. At first, it might seem like a bright planet, but within hours it becomes undeniable. This star, this distant object we've been quietly observing, has exploded. A supernova, and not just any explosion, but a cosmic spectacle so brilliant it outshines every other star in the night sky. For days, maybe even weeks, it would remain visible with the naked eye. No telescope needed. People across the globe could step outside and see it, whether from the bustling streets of a city or the quiet silence of a rural field. In darker skies, it could be so bright it casts faint shadows on the ground. During the day, it might still be visible, hanging in the blue like a ghost of a second sun. It would be a moment unlike anything humanity has witnessed in modern history. 8E, front row seat to the death of a star. Emotionally, it would be overwhelming, not in fear, but in awe. A reminder of our place in the universe and of the vast, unpredictable beauty that surrounds us. For scientists, it would be the opportunity of a lifetime. For the rest of us, it would be a cosmic gift, a glowing echo from a star's final breath, lighting up our skies and connecting us to something unimaginably ancient and powerful. The explosion of a star like this isn't just a visual marvel, it's a scientific treasure trove. These kinds of stellar deaths are some of the most powerful laboratories in the universe. When a massive star explodes, it releases not just light and energy, but the very elements that make life possible. Gold, platinum, uranium, these don't come from Earth. They're born in the hearts of dying stars, forged in the unimaginable heat and pressure of a supernova. Then they're scattered across the galaxy, seeding the building blocks of planets, oceans, and life itself. In fact, every atom in our bodies, carbon in our cells, calcium in our bones, iron in our blood, was once part of a star. We are literally made of star stuff, recycled from ancient suns that lived and died long before Earth ever formed. So when we witness a star nearing its final act, we're not just watching a distant event. We're seeing the same cosmic process that made us possible. For astronomers, observing such an explosion in real time would offer priceless data on how matter behaves under extreme conditions. It would help refine our understanding of stellar evolution, black hole formation, and even the origins of life. We've studied giants like Antares, Betelgeuse, and VY Canis Majoris, enormous stars all potentially nearing their own explosive ends. But this new star adds a strange and compelling twist to the story. This isn't just a star dying, it's the universe creating again, destroying, transforming, and setting the stage for something new to emerge. While the idea of a star exploding might sound alarming, there's no real danger to Earth from this event. The star is thousands of light years away, far enough that even a powerful supernova wouldn't harm our planet. The radiation would dissipate long before it reached us. What we'd see is the light show, not the threat. In fact, any side effects would be more fascinating than frightening. Depending on the strength and type of explosion, Earth's atmosphere might experience a brief increase in ionization, possibly enhancing auroras near the poles, like nature's own celebration of the cosmic event. No damage, just a little more. Color dancing across the sky, and thanks to modern science, we might even get a heads up. Before the visible light of a supernova reaches us, it releases a burst of neutrinos, tiny, nearly massless particles that travel faster than light through dense material. Detectors around the world are constantly scanning for these particles. If a nearby star goes supernova, they'll alert astronomers within seconds, giving us time to prepare our telescopes and witness the unfolding spectacle. So, yes, it's dramatic, but it's also safe. A breathtaking cosmic event we can observe with wonder, without worry. We're witnessing the final breath of a giant, a farewell millions of years in the making. This distant star, pulsing across the void with strange signals, has lived an ancient life we can barely imagine. It was born long before humans spoke their first words, and now it may be approaching its grand finale, a cosmic eruption that will echo through the galaxy for eons. Moments like this remind us how small we are, and yet how deeply connected we are to the universe around us. We're not just bystanders. We are made of this same cosmic material. The stars live, burn, die, and in doing so, they shape everything we know. From the atoms in our blood to the light in our skies, we are part of a much larger story, one written in fire and silence across billions of years. So the next time you step outside on a clear night, take a moment. Look up. That twinkle you see might be the whisper of a dying star or the birth of a new one. There is so much happening out there right now that we have yet to discover. The universe doesn't just belong to scientists. It belongs to all of us. And it's still speaking, if we're willing to listen. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think about the mysteries unfolding in our universe.